Hey guys, this is the second video for your week. This is called Elements. Now, we just got finished talking about the structure of an atom, and so we went really small. Now, what happens when an atom builds up and we've got several atoms that are the exact same and they're all together? Then we end up having an element, and an element is the purest form of matter. There is nothing that goes into it other than specific atoms, and we'll get to that in just a moment. I wanted to show you an example, or 4 examples, of some elements. In the top left-hand corner, you see the black, and then you see what looks like a diamond. That's an example of carbon. Carbon is an actual element. It is a non-metal, and we'll talk about that next week. And carbon exists as is. Carbon makes diamonds. That's why you see the diamond on the left. And then the top right corner is an example of neon. Neon gas is what fills the bright signs that light up a lot of locations and a lot of places. You'll see the example is the open sign. Anytime you see an open sign, typically speaking, that's going to be an example of neon. The bottom left-hand corner is aluminum foil, and I'm sure all of you recognize aluminum foil because most of you have seen it in your kitchen. We use aluminum foil to cover things and to keep things cool or to keep things warm depending on what we're dealing with. And then in the bottom left-hand corner, you'll see a yellow substance. This yellow substance is called sulfur. Sulfur is another example of an element. So what exactly do I mean by element? Well, an element is the purest form, as I've said, of matter. Nothing else makes it up other than atoms. Well, you know after this last week that elements exist as solids, liquids, and gases. So let's take a look at what that means as far as elements go. So elements exist as solids, liquids, and gases. And what I've done is I've given you a graphic organizer for you to see. I have a sample of carbon, which I've shown you a picture of. I have a sample of mercury, and I have a sample of helium. With the sample of carbon, carbon exists in nature as a solid. Well, what does that mean? The solid tells us that the atoms of carbon are arranged in a very specific order, and they're very perfectly lined up, and they fit, and they have a definite shape and a definite volume. And what I've done is each one of the letter C's represents a carbon atom. So in a sample of carbon, every atom that makes up that sample is a carbon atom, and it cannot be any other kind of atom. They all have to be carbon atoms. Then we move to liquids. Liquids are made up of atoms, and the atoms are a little bit further spread apart from each other. There's not quite as much order as there is in a solid. So liquids are really fluid. They can fit whatever shape you put them in. So their volume is dependent on the container or the shape, but it has a definite mass. Liquids have definite mass. Hg is the chemical symbol for mercury. Mercury is a metal that exists as a liquid. It used to be inside of thermometers, but mercury is toxic. So what you'll see is that every atom in that sample of mercury is a mercury atom. It can't be a carbon atom. You don't see any C's that are inside of this sampling. All of the atoms that exist in mercury, in a pure sample of mercury, are going to be mercury atoms. Then we come to gases. Now with gases, the particles or the atoms are spread even further apart, and they're typically moving pretty quickly. So this is a sample of helium. Helium is a gas. It exists in nature. It's part of our atmosphere. And the chemical symbol is capital H, lowercase e. Well, in a sampling of helium, every single atom is a helium atom. In a pure sample, I will not find carbon atoms in helium, in a sample of helium, and I will not find mercury atoms in a sample of helium, because elements are made up of atoms, and each atom that makes up that element is the exact same kind of atom. So, ladies and gentlemen, we will be looking at the periodic table next week. So that's a wrap.